Up on 6.5, this is the law of cosines, the end of the chapter. So we talked about last week that the law of sines works really well, but then we all of a sudden realized that when I take the inverse sine, I could potentially come up with two different angles that have that value when I take the sine of it. So therefore, we have three cases. We had cases where there would only be one answer. Then we would have cases where there are two answers, or two different triangles. And then we had cases where there would be no triangles at all. Well, here's the cool thing, is that they also came up with law of cosines. And the law of cosines always will give you the one answer if it exists. So there still could potentially be trying to put pieces of a triangle together that don't work. They'll tell you that. But if it does, this one will tell you the right answer. Okay? And there's going to be reasons why for this. Now, this, again, all hinges on the fact that we have this non-right triangle with the side angle pairs opposite each other. And again, these side angle pairs can move around, change around, as long as A is to A, B is to B, C is to C. I personally do not sit there and try to remember all of them. I just remember that one. The very first one. And to me, the very first one, if I remember this one, the others will follow. So whatever side I'm trying to solve for, I just square the other sides, add them together, and subtract 2 times those sides times the cosine of the angle. It's not too bad. Now again, we can change it around for any of the particular variables or sides. But we always set it up as a squared equals b squared plus c squared minus 2bc times cosine a. I intentionally left space between the 2bc, 2ac, and 2ab and cosines. Those are multiplied together. Okay? So we just need to plug in. And the cool thing is, if you know all 3 sides, you can solve for an angle. If you know 2 sides and an angle, you can solve for a side. Different places, different things. So let's do an example. The surveyor standing at point C wants to build a tunnel through a mountain. To estimate the length of that tunnel, the dotted line, a surveyor makes the measurements shown below. Use the surveyor's data to approximate the length of the tunnel. These are things that they would have done back in the day, right? Obviously, we can't march our way through a tunnel before they build it. But you can stand away from the tunnel and say, hey, how far away from you at point A and you from point B, measure the angle between them, you're going to be able to figure that out. So we got side B, side A, angle C. I technically want to know side C. So what I would propose is to write down the formula with C as our side that we want to solve for. And it's all based off the same thing. So C squared is equal to the side squared, which is A squared plus B squared, minus 2, the same sides, times AB, cosine of the angle C. Fill it in, solve it out. That's all we have to do. We don't know C squared. I'll leave that alone. But we do know A. What's A? 212 plus 388 squared minus 2 times 212 times 388 cosine 82.4 degrees. You can just put this all in your calculator and you'll have an answer. I highly suggest that you don't just throw it all on a calculator, only because you're bound to make a mistake someplace. I would take it in parts. I would do the 212 squared, the 388 squared, and then I would do 2 times 212 times 388, and then leave cosine 82 kind of at the end. Then the next step, multiply it by the cosine 82.4, gathering up the other numbers, and keep working that way. I'm not going to say your calculator will be wrong, but you have a higher chance of putting something in wrong when you do it all at once. What happens to be 212 squared? See it? Right, it's the only one I remember. Plus, what's 388 squared? 544 minus, what's 2 times 212 times 388? And then that is multiplied by cosine 82.4. At this point, I'm going to add the 44 and the 150,000, and then also multiply the 164,000 by cosine 82.4. Is that okay? So c squared is equal to, what's 144 plus the 150? The first two numbers. 190, 488 minus 164,512 times cosine 82.4. Make sure you are in degrees. How big of a number is that? It's going to be bigger or smaller? 21575. So 21,000? And a 7. 0.7? Hold on.
No, that's the wrong order.
Wrong order. Okay, hold on. Let me back this out. 2, 1, 7, 5, 7. Is everybody okay with that? Now, is that the actual real answer, or is there approximation there? I got a feeling that cosine of 82.4 doesn't come out to be perfect. Probably an approximation, but we'll go with this. Subtract the two numbers out. C squared is equal to 173 or 4.
3730.
That's for c squared, and then take the square root. Should we put plus or minus on this thing? We're solving for a variable. The answer is no, because c is a distance, and distances are not negative. Plus, you don't have a negative length of a side. What do we end up finding? 416, that's right. 416 point something. 0.8 feet. Now, does this make sense? Now, we're not supposed to look at our diagrams and say, hey, 82.4 seems to be my largest angle, according to that diagram. That means C should also be the largest side. Okay? Next is, what if I just give you the sides of a triangle? Can you find me the angles?
Yeah.
I would think so. So, it's not given, I better make a triangle. And start filling it in. A is 5. B is 8. And C is 12. Which one do you guys want to solve for first?
100.
You can't solve them for 100. I'm not solving for 100.
Yep.
A. A because it's the original formula. A squared equals what? B squared plus C squared minus 2BC cosine big A. I'm not going to, I'll rearrange at the end. We could just solve, you're right, you could just solve for cosine A right away. That works out fine. I'm going to put all the numbers in and then solve it individually as we go along. So 5 squared equals 8 squared plus 12 squared minus 2 times 8 times 12 times cosine of an angle I don't know, but I want to know. 25 equals 64 plus 144 minus, no, not minus 2, minus 192 cosine A. Will you guys be okay with subtracting 64 and 144 to the other side in this step at the same time? So what's 25 minus the 64 minus the 144? It's a negative 186. 3 equals negative 192 cosine of A. Divide both sides by negative 192. That makes it a positive. To get cosine by itself, A would equal the inverse cosine of 183 over 192. We'll know this should work because why? What's 183 divided by 192? It's less than 1. It can't be above 1. Make sure you're in degrees. What is it? 7.5? 17? 17.6? I heard 17.5, 17.6. Anybody else? Okay, so we say 17.6 is A. Do you guys want to do that again for B and C? Okay. Question came up is can we just use law of sines now because we have a pair. Now, could we use law of cosines again? Yes. Guys, if you've used law of cosines for B and C, you get answers. They work out beautifully. Let's take in consideration that you guys want to use law of sines. Yeah, here's the problem. We're going to do a sine of 17.6 over 5 is equal to, let's solve for B, sine of B over 8. So, you guys tell me if you take the sine of 17.6 divided by 5 multiplied by 8, take the inverse sine of that, what do you get? I'm rushing through this. I'm not showing all of my work, but you guys should on your quizzes and tests, right, and homework. But just to save a little bit of time in the video, we're going to multiply both sides by 8, cancel that out. But what if I take the inverse of that thing? 28.95. This is the law of sines. You have an angle already of 17.6. That leaves you with options. I can be 28.95. That works out wonderfully. But as a reference angle in the second quadrant, that would also leave me with what other size angle? 151 28.05. Does that sound about right?
Yep.
Because you're in the second quadrant. Now wait a minute. Let's think this through. What if 151 was my choice? Can you tell me the other angle? Actually, if you plug in these values of B, either one, in for B, could you find C? So let's do that. I'll change colors so we can color code. If this one is 28.95, what would C have to be? 133.45. I'll change it to green. If we chose this to be the 151.05, what would C have to be? Because it does work, right? It's going to be smaller. What is that angle C going to be if we add them up all to 180? 11.35. So either we have 17.6, 28.95, and 133.45, or 17.6, 151.05, and 11.35. What we did yesterday, talked about, or the day before, you would have to list both of these, right? Or do we not have to list both of these? One of these is not your answer. One of them is. Can anybody explain why? The green stuff doesn't work. You cannot be 151. Yeah. Ashley.
Add up more than 180 and do them all together.
It should. The red and the green should add up to 180. The red and the purple should add up to 180. Individually. That shouldn't be, right? Because we're taking 17.6, 28.95, and 133.45. Why is the purple and the red the only option? Okay.
Because on C it's your longest side, so then that means that the C angle has to be your biggest angle.
Yes. Guys, since C is the largest side of your triangle, what has to be true about the angle opposite? Has to be the biggest. The purple one would make it that true. If I went to the green, it'd actually be the smallest angle, which would not correspond with the largest side. Because again, not only does the largest angle get the largest side, the smallest angle has its smallest side. Do we get that, guys? Therefore, green is out, and you're left with 17.6, 28.95, and 133.45. Now again, we approximated those. They might not add up perfectly to 180, but they should. Okay? This is exactly saying what I said there. Longest side, largest angle, smallest side, opposite the smallest angle, so forth. We ended on this problem with the other class, and it says that a pilot sets out from an airport, heads in the direction of north, 20 degrees east, flying at 200 miles per hour. After 1 hour, he makes a course correction and heads in the direction of north, 40 degrees east. Half an hour after that, the engine troubles forces him to make an emergency landing. Question 1, find the distance between the airport and where he landed. 2, find the bearing from the airport to his final landing point. Part B uses the same kind of thing which we did for problem 31 in class. We're taking questions with the parallel lines and stuff. Something you guys need to know to do this problem. Anytime we're talking about flights and bearings, you need to realize that we're talking about north, south, east, west coordinates. And when I say, for our problem here, maybe I'll just redraw it so I can use it. The airport is in the middle of that X, okay, the red X. what you're going to do is you're saying, hey, I'm going north, but then I'm going east 20 degrees from north. And so the plane actually is going here, where that is 20 degrees. So the plane now is traveling for 1 hour in that direction, right? Then it says that after an hour, he makes a course change, right? Going 40 north, 40 degrees east. So now he's going more this way, but has an angle of 40 degrees. It's not as pronounced as it was last time, but how do you get part A, which says, hey, there's my airplane at this point. How far away from the airport are you? That's a really bad looking triangle, but it works, kind of. Find the distance between the airport and his final landing. How do we know our angles? You got to use that whole parallel line stuff. All east-west lines are parallel. I want to know this x right there, that distance, the black line. Do we know any distances on these? How far did he go in the red? 200. How far does he go in the green? 100, because it's half an hour at 200 miles an hour. Those are hard numbers to see on there, I'm sorry. So essentially, I'm hoping everybody sees that, from what we can tell here, is that I got a leg, another leg. I want to know the third leg. So it means I need to find the angle between, right, the two sides I know. And if I do know that, I could solve for x pretty easily. So how do I figure this out? Turns out to be not too bad. These are parallel, yes? Think of alternate interior angles. Let's switch to purple. Would you guys agree that this angle is the same as that angle? To the red line? Would that be true? So, you know that this is to the red here. It's 90. And I go 20 more, which would be what? 110. Which means there's 110 on the bottom. Wow, that's really crammed in there. 110 degrees. But is that the whole entire angle? No. The other part of that angle is this part right here, which is 90 minus the 40, which is 50. So the larger angle ends up adding these together, 160 degrees. That really needed to be bigger, I think, for us to see it, but hopefully on your paper it's bigger. And now, you know an angle between two sides to find its opposite pair. I'll call them A and little a. Big A and little a. I'm not actually going to finish the whole process here, but you should say, hey, wait a minute. I don't know what a squared, we called it x, I guess. Call it A now. Then we get 200 squared plus 100 squared minus 2 times 200 times 100 times cosine of 160. You should be able to solve for A pretty easily, right? And once you know that, you can solve for the angle right in here. And if you know the angle in here, you know your bearing, because your bearing would be north by east, but 20 plus whatever that thing is will end up running you into your landing zone. Homework's page 518, 7 through 23 odds. Have a great day.